Hello, my name is Chris Fitzpatrick, and welcome to my Physics 2212 Lab 2 presentation. The purpose of this lab is to observe the manually charged adhesive tape's interactions with other tape, determine the charge on tape, and answer experimental and hypothetical questions about the properties of the tape. Here are the first part of the experiment instructions. Use a strip of tape about 20 centimeters long. Shorter pieces are not flexible enough, and longer pieces are difficult to handle. Fold under one end of the strip to make a non-sticky handle. Stick a strip of tape with the handle down onto a smooth, flat surface such as a desk. This is a base tape. Smooth this base tape down with your thumb or fingertips. This base tape provides a standard surface to work from. The next step. Stick another tape with a handle down on top of the base tape. Smooth the upper tape down well with your thumb or fingertips. Write U for upper on the handle of the upper tape. With a quick motion, pull the U-tape up and off the base tape, leaving the base tape stuck to the desk. Hang the U-tape vertically from the edge of the desk and bring your hand near the hanging tape. If the tape is in good condition and the room is not too humid, you should find that there is an attraction between the hanging strip of tape and your hand when you get too close to the tape. If there is no attraction, remake the U-tape. Make 2 U-tapes. Be careful to handle them by only the ends. Make sure each tape is charged by bringing your hand close to it. If the tape does not interact with your hand, remake the tape. Observe the interactions of 2 U-tapes. Record your observations. And I recorded that the 2 U-tapes repelled each other when brought near each other. Observe the interactions of 1 U-tape with neutral objects such as a table or a book. Record your observations. And I recorded that the U-tape was attracted to neutral objects such as a textbook and a table. Determine the force exerted by 1 U-tape on another when they are a measured distance apart. By making 2 simplifying assumptions, use this force to determine approximately the amount of charge on one tape. And those 2 assumptions are: each U-tape has the same net charge, and all charge is located at a single point at the center of the tape. Determine the magnitude of the gravitational force on tape B. Carefully measure the separation distance at which tape B begins to float. Use these measurements to determine the charge on tape B. Calculate the corresponding number of electrons on tape B. And I got tape length was 0.2 meters, tape width was 0.022 meters, and distance was 0.022 meters. The tape weight is 0.2 meters times 0.001 kilograms per meter times 9.81 meters per second squared, which is 1.96 times 10 to the negative third newtons. The surface area is 0.2 meters times 0.022 meters, which is equal to 0.0044 meters squared. What fraction of atoms give up electrons? Given that an atom has an approximate length scale, that is length dimension, of around 1 times 10 to the negative 10th meters, calculate the number of atoms on the sticky surface of your tape. Determine the magnitude of the gravitational force on tape B. The surface area divided by the number of atoms is equal to 0.0044 meters squared divided by 1 times 10 to the negative 20th meters squared, which is 4.84 times 10 to the 17th atoms. The force, which is equal to the negative gravitational force, is equal to 0, 1.96 times 10 to the negative thirds, 0 newtons. Compute the ratio of the number of electrons, excess or deficient, to the number of atoms on the sticky surface. Use these measurements to determine the charge on tape B. The charge is equal to the square root of K times F times G times D squared. And that is equal to negative 1.08 times 10 to the negative 8th coulombs. The excess charge is equal to the tape charge divided by the charge of an electron, which is equal to negative 6.9 times 10 to the negative 7th coulombs, divided by negative 1.6 times 10 to the negative 19th coulombs, which is equal to 6.875 times 10 to the 10th electrons. And the ratio is equal to the excess electrons divided by the total atoms, which is equal to 6.73 times 10 to the 10th electrons divided by 4.84 times 10 to the 17th atoms, which is equal to 1 electron divided by 7.19 times 10 to the 4th atoms. And the assumptions that allowed me to perform this calculation are: each U-tape has the same net charge, air resistance is not large enough to affect calculations, atoms are positioned in a perfect lattice, and the mass is calculated using a set length to mass ratio. And all of these will be very important when calculating the GLOW script code. Here is the part 1 of GLOW script code, part 2, and part 3. And here is the visual result from the GLOW script code. And here are the follow-up questions. What if you modeled each of your tapes as a single point charge? And the answer is there is a significant increase when modeling as a line charge. 3.99 times 10 to the negative 4th newtons is the new charge versus 2.62 times 10 to the negative 4th newtons, which is the old. And why is there a difference in estimations when modeling as a point charge? And the answer to that is there are a difference in estimations because we aren't using the point charge model and instead are using a more accurate length-based summation model. And the better estimation is the line charge model because of the accounting of the length of the tape and the equal distribution of the tape, which makes the model more accurate to real life. Thank you for watching, and I hope you enjoyed this video.